This is question 15 of civil engineering paper of GATE 2022 afternoon session. Match all the possible combinations between column X cement compounds and column Y cement properties. Column X C3S, C2S, C3A. Column Y early edge strength, later edge strength, flash setting, highest heat of hydration, lowest heat of hydration. Which one of the following combination is correct? So in this question, two columns are given, namely column X and column Y. In column X, various cement compounds are given, and in column Y, various cement properties are given. We need to do the correct match among these terms. So in column X, the compounds given is called box compound. You may study in detail about this box compound by watching lecture 5, Portland cement, hydration, porosity and strength of cementitious material by Professor Sudhir Mishra and Professor K.B. Harish IIT Kanpur. So just let's quickly recall about these compounds. So in cement, various oxides are present like calcium oxide, silica oxide, aluminum oxide, ferric oxide and others. So but these oxides are not present as oxides, rather they present in the forms of compounds in the cement, which are tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminoferrite. The chemical formula, shorthand notation and weight percent of each compounds are depicted here, and these compounds are known as box compounds. Each compounds play a different role for the cement. Like C3S, due to presence of C3S, cement hardens rapidly and is largely responsible for initial set and early strength. So we may say with the higher percentage of C3S, the early strength will be higher. The other compound, which is C2S, so due to presence of C2S, cement hardens slowly and contribute largely to a strength increase at age beyond 7 days. That is a strength at later age. We may say a strength at later age, as it is also written here, hardens slowly. So it also releases a low heat of hydration at initial stage. C3A, that is tricalcium aluminate, which is another box compounds. Due to this C3A, cement leverage a large amount of heat, that is heat of hydration is high at the initial stage, first few days of hardening, and it affects also setting time. This C3A, when the water is added to the cement, this C3A act quickly with the water and responsible for flash setting. To reduce this flash setting, gypsum is added to the water. Another box compound, tetracalcium aluminoferrite, that is C4AF, it contributes very slightly to strength gain. It is responsible for the grey color of the cement. All these four box compound can be estimated by using Box equation. There are two cases when the ratio of alumina to the ferric oxide is greater than equal to 0.64, then we use these four equations to estimate the box compound, and when the ratio of alumina to the ferric oxide is lesser than 0.64, then we use these four equations. Now coming to the question, C3S, so just we have studied C3S is responsible for early age strength, hardens rapidly, and it is responsible for early strength. So C3S, the correct match for C3S, early age strength, that is P. C2S, C2S is responsible for the strength at later age. So later age strength. So match is Q. Also C2S produce low heat of hydration. So which is given in lowest heat of hydration T. So correct match will also be T. The properties of C2S is also lowest heat of hydration, that it produce low heat of hydration. C3A. So C3A reacts quickly with the water when it is added to the cement and responsible for flash setting, that is R. And it also produce high heat of hydration, which is in option S. So if we see the options, so for first P, for second Q and T, for third C3A, R and S. So all these combinations are given correctly in option A. So option A is the correct answer for this question. Thank you.